Hello friends, in the last video you have seen the basic terminology and we have seen the void ratio with respect to three-phase diagram. So void ratio, porosity, degree of saturation, air content, so many terminology we have seen related to geotechnical engineering, and these have got high relevance to understand the behavior of a soil mass, how the soil mass will behave. So these terminology, the another one was specific gravity, then unit weight, gamma. So these terms you have already seen in the last video. Then there is another term which is known as moisture content or water content. So what is this water content? If at the site, you go to the site, this is the ground surface, and the voids are completely filled with water, the degree of saturation is going to be 100%. And what is the water content? Water content with respect to three-phase diagram, you have a soil solids, you have got the void which is filled with water. So in terms of weight, this becomes the weight of the soil solids, the weight of water, and the weight of air is going to be 0. So the ratio of the water content or the moisture content, which is designated by small w, is the weight of water present in the soil mass with respect to the weight of soil solids. So it can be written as the weight of water divided by weight of dry soil. And because it is expressed in percent, you can multiply it by 100. So if I say the moisture in this soil mass, this is the three-phase diagram of this ground. So this depicts this ground, and if I say that the moisture content is 30%, the water content is 30%. What does it signify? 30% means it is going to be 30 equal to weight of water divided by weight of soil mass into 100. Therefore, weight of water is going to be 0.3 times the weight of soil solids. So that's how the weight of water content, this water content can be defined. So these are going to have interrelationship. So the another term is moisture content or water content. So what is the relationship between various parameters? If you see in terms of void ratio, so in terms of void ratio, there is the volume of the void, there is the volume of the solid part, there is the volume of the void in a given soil mass. So there is the void. This void could be partially filled or fully filled with water, and there is the volume of the soil mass. So what is the void ratio? So if you say void ratio, the symbology, and in the last video we have seen that the void ratio is volume of void to the volume of soil solids. Now, if I consider it as the unit volume of the soil solids, if volume of the soil solids is unity, 1 unit, then E equal to volume of voids. Therefore, in the three-phase diagram, I can show it like this, that this volume of void is going to be E and this is going to be 1. Therefore, in terms of void ratio, this is going to be total 1 plus E. So, in three-phase diagram, you can show it that the total volume, this is the total volume equal to 1 plus C, where the volume of solids we have taken as unity, and therefore we find that the void ratio becomes equal to volume of voids. So therefore, what is the relationship between void ratio and porosity? We know that porosity N is defined as volume of void with respect to total volume of the soil mass. So what is the total volume here? It is 1 plus E. So if you want to write it in terms of E, then therefore the interrelationship between N and E can be written. Therefore, the porosity N equal to volume of void is going to be E. Therefore, I can write it as E. And the total volume in terms of E is going to be 1 plus E. So there is the relationship from three-phase diagram, N equal to E divided by 1 plus E. If you want to write it in terms of N, then also you can do it. Let's do it in terms of So one of the important relationship you have got, that N equal to E divided by 1 plus E. Now what is N? N is volume of void to total volume. So this is the total volume. If I take the total volume as unity, so this is the three-phase diagram. This is the solid part, this is the void, and the total volume, if I take it as unity, this becomes 1. So if I take V equal to 1 unit and N equal to VV, so volume of void becomes N. So total is 1, so the volume of solid becomes 1 minus N. So this is the volume of solids, and N is the volume of void, and this is the total volume. Total volume equal to 1. Now, if I want to develop interrelationship between N and void ratio E, I can write it. Now, therefore, with respect to this diagram, the void ratio E is defined as volume of void to the volume of solids. So therefore, volume of void here is N. So I can write it equal to N divided by volume of solid is 1 minus N. Therefore, the relationship between E and N is so simple. In the similar fashion, I can write a relationship between E, degree of saturation, SR, G, and moisture content. So what is the relationship? It's very simple. E into SR equal to moisture content into G, where G is the specific gravity. So there is another relationship. Similarly, you can have relationship between the total unit weight. Last time you have seen that the total unit weight, gamma T, is the ratio of total weight divided by volume. So if you know the total unit weight, this we can write it that the dry unit weight equal to the total unit weight divided by 1 plus W. So this is another relationship between dry unit weight and the total unit weight, where W is the moisture content in fraction. So this is another relationship, important relationship, that we need to know it. Then similarly, we can say that gamma T can be written as G plus E into SR into gamma W divided by 1 plus E. The total unit weight is going to be the total weight divided by volume. So the total unit weight is for the moist soil mass, the degree of saturation is going to vary. So if it is in dry condition, then gamma D. Then for dry condition, dry soil mass, this is for moist soil mass, gamma T, the total unit weight equal to G plus ESR gamma W divided by 1 plus E. But if the soil is completely dry, what will be the degree of saturation? Degree of saturation will be 0, because degree of saturation is defined as volume of water divided by volume of void. So volume of water will be 0 because it is dry. So degree of saturation will be 0. Naturally, this gamma T becomes gamma dry equal to G gamma W, because this becomes 0, divided by 1 plus E. There is another important relationship. To understand the behavior of the soil mass, we use these terminology, gamma T, gamma T. Now, if it is completely saturated, if the soil mass is fully saturated means void will be filled completely with water. There is no air. Then in that case, the volume of water and volume of void will be equal. Therefore, degree of saturation will be 100% and it will be equal to 1. Naturally, if you substitute here, now for fully saturated soil mass, gamma T becomes gamma saturated, and here it becomes G plus E into 1, so it becomes E gamma W divided by 1 plus E. There is another important relationship. Similarly, if you want to find out the submerged unit weight, the submerged unit weight is gamma prime, and that's written as gamma saturated minus gamma W. Naturally, if you gamma saturated you already know, and if you direct gamma W, then you will be able to calculate the value of gamma prime. So gamma prime can be calculated. So these are very, very important relationship. Gamma prime equal to gamma sat, we know G plus E gamma W divided by 1 plus E minus gamma W. So that is the submerged unit weight, and therefore you get G minus 1 gamma W divided by 1 plus E. So the submerged unit weight gamma prime can be, there is another important relationship that you should know it. So many relationships comes into picture that must be kept in mind, and then only you can predict the behavior of the soil mass. In the next video, we will see some of the applications of these interrelationships. So these interrelationships must be remembered so that you can understand the behavior of the soil mass and you can apply it in order to understand the various properties of the ground. So in the next video we will do that. Thank you.